Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. So this question is asking us really to divide the 5 3/4 by 1 3/4. So we're going to do 5 3/4 divided by 1 3/4 because we're finding out how many of each of these towels, which is 1 3/4 meter, can be made when the total amount of cotton is 5 3/4. So first thing we're going to do is convert them to mixed numbers, to top-heavy or improper fractions, because at the moment they're mixed numbers and we can't divide or times if they're mixed. So we times the 5 by the 4 and add it to the top, which will be 20, and then add it to the top 23, and then do the same. 1 times 4 is 4, plus it to the top is 7 over 4. Now a little trick here is KFC. We keep the first fraction, we flip the second fraction, and we change the divide sign to a times sign. So we're going to keep this first fraction as it is, change that divide to a times, and flip the second fraction. Okay, whenever we multiply, we just multiply the tops, so 23 times 4, which is 92, and we times the bottoms, which will be 28. And now we need to convert this back into a mixed number. So first of all, actually we can simplify this because we can divide top and bottom by 4. So that would be 23 over 7, and then make this a mixed number. So 7's into 23 go 3 whole ones, and then obviously 2 remainders, so it's 2 over 7. Now it asks us for the amount of towels that she can sew patterns into. Now the issue here is that she will do 3 whole towels but then have some left over, but she doesn't have enough to create a 4th towel, so it's just going to be 3 as an answer. For each of these options, try and construct in your head the triangles that would be made from these lengths. And I'm going to give an example for question D, or for option D. And I'm going to construct my triangle just with sticks. So we're going to start off with our first stick, which is 19 centimeters. Then we're going to do another stick, which is going to be 37 centimeters. And we've got one last stick, which is 61 centimeters. Now, looking at the first 2 sticks, the actual combined distance of them, so when we add them together, so be 19 centimeters plus 37 centimeters, is 56 centimeters. So that's the combined width of them. And you can see that that actually wouldn't be able to create a triangle if the third stick is 61 centimeters. So the side here could combine with this side. So we could move this whole stick here onto this side here, but we can't actually make a triangle with it because the 2 lengths that we've got won't ever reach the end bit here. They just won't ever reach that bit to be able to create the triangle. And I'm just going to put that back. So our answer is option D. So it's really important, first of all, we make clear about how we convert things. So if I've got a unit in kilometers and I want to convert it into meters, then we know we just times it by 1,000. So 2 kilometers is 2,000 meters. But if I have something in kilometers squared and I want to convert it into meters squared, I actually times it by 1,000 squared, which is 1,000 times 1,000. Okay, so I'm actually timesing it by not 1,000, but 1,000 squared. So that's another 3 zeros. You can see here that that's 1,000,000. So we times it by 1,000,000. So 13 kilometers squared is going to be the 13, and then it's going to be times by a million. So 1, 2, 3, 1, 2, 3. So it's going to be 13 million. Now, it says here the farmer must pay 1 pence tax for every metre squared. So this is going to be 13 million metres squared. And so that's going to cost him, or her, 13 million pence. But the answer is going to be in pounds. So we just need to get rid of 2 of the zeros at the end. So it's going to be 13, 1, 2, 3, 4. So it's going to be £130,000. So the rules of indices state that if you have a power inside and outside of a bracket, we just multiply them together. So it's 10 to the power of minus 12 times minus 12. 2 negatives make a positive, and 12 times 12 is 144. So when you read this question, the question's basically asking you to find the bearing of O from B. So the lifeboat is at B, so I'm going to draw a north line here. And to find a bearing, you start from the north line and you keep going clockwise. So we're going to look for this angle here. Now, this angle, which is given to us in the question, and this angle here, which I'm just going to call x, are going to be equal. So x is going to equal 135 degrees. And the reason for that is we've basically got, and I'm just going to draw or extend the north line down, because we've basically got well, we have a set of parallel lines here, and we have a set of z angles, which we know is alternate angles. So the reason for that is it's alternate angles. And always show the reasons to the examiner. Okay, and so to find out what the bearing is, so the bearing of O from B, it's just going to be 360 take away 135, and the reason for that is angles on a point. We've run out of space. Okay, so we're going to do 360 take away 135, which is 225, and so our answer is 225. Sometimes it's easier with these questions to multiply both numbers by, say, 10 or 100 or 1,000. So if we look at the 0.06, if we times that by 100, it would make the question a lot easier. But with a division, if you times one of the numbers by 100, you have to times the other one by 100. So we just go times the 30 by 100, and times the 0.06 by 100 to make that 0.6. And this actually is the same calculation as 30 divided by 0.06. The reason being is that you can write that as a fraction. And you know with fractions you can just times the top by something and times the bottom by something. It doesn't change the fraction at all. It just keeps it exactly the same. So we're going to use the bus stop method to find out what that is. So we're going to divide that out. 6 doesn't go into 3, so carry that. 6 is into 30, go 5, 6 into 0, 6 into 0, so that's going to be 500. To find the highest common factor, we're going to first of all just write out the factors of 12. So 1 times 12 is 12, 2 times 6, and 3 times 4. And we're going to do the same with 8. 1 times 8 is 8, and 2 times 4 is 8. So those are all the factors of 12 and 8. And we look at the common factors, so they both have 1, they both have 2, and they both have 4. And so the highest of those is the 4. So the highest common factor is 4. A frequency polygon is like a line graph. In fact, it's a type of line graph. But it is when you have the data in a group. So we've got the data here as a group of 0 to 80. So there are 11 at 0 to 80, and then 18 at 80 to 160, and 6 at 160 to 240. Now, where am I going to plot this? It will involve putting a cross somewhere on this graph, and it would seem unfair if I put it all at 0, and it would also seem unfair if I put it all at 80. So what we do is we find the midpoint, the halfway point between 0 and 80, which is obviously 40, and we plot our coordinate there. So it seems to be going up in 2s, so it would be there. So that's at 40, 11, the coordinate. Our next one, we plot at the midpoint again, which would be 120, and it's just halfway between 80 and 160, and it's 18 high, so it would be up here. And then the final one is at 200, and it will be 6 high, so 200 is halfway, and we're looking at 6 high, so it will be here. Then when you're done, you need to join them up with straight lines. So I'm just going to get my ruler, join them up, perfectly straight lines, and there we are. So we're going to first of all convert the 11 litres into millilitres. So we're going to do 11 times 1,000, which would be 11,000. Okay, so we're going to just draw a line, like a number line. And we're going to have the 11,000 in the middle. Now, what would be the next one down if we're looking at to the nearest 10 mil? So we're going to add a 10 mil on, which will be 11,010, and we're going to take the 10 mil away. So 11,000 take away 10 mil will be 10. What is it? 990. Now, when we're looking at limits, with the upper and lower part of it, we are looking at halfway points. So halfway here and halfway here. So this halfway point will be 10,995, and the next one will be 11,005, and that's the halfway points. And so that is going to be our upper and lower bound. And we just need to say that V can be anything above the 10,995 and including that, and it can be anything below 11,005, but it can't include that, because if it did, if it was 11,005, it would have rounded up to 11,010. In this question we have a right angle triangle and we know 2 of the sides and we're looking for the third one, so that screams to me Pythagoras. So Pythagoras is a squared plus b squared equals c squared, with c squared being the hypotenuse. The hypotenuse is the one opposite the right angle, so this is going to be c. And we'll label the other ones a and b, it doesn't matter which way around they go. So a is 5, so it'd be 5 squared plus 12 squared equals c squared. 5 squared is 25, 12 squared is 144. And so 25 plus 144 is 169. Now that's c squared, so we need to solve here, and the way to solve is just to square root both sides. And so it would be 13 equals c. Because it's distance, we don't worry about the negative 13, so just the positive 13. So we know c is 13, so we need to know what the total length around the triangle is. So we're going to add the 5, the 12, and the 13 we've just found. When you do that, you get 30. So we know there's 30 meters in total. Now it does say that we need 90 milliliters of paint per meter of wood. So the amount of paint needed is going to be the 30, because that's the total distance, times the 90, because we need 90 for every meter of paint. 3 times 9 is 27, and then put the 2 zeros at the end. So the answer is 2,700 milliliters. So to answer this question, you need to just know the answer off by heart. There is a diagram that can help us actually get there. And if we just draw a right angle triangle and put the lengths as 1, not right angle here, we can use Pythagoras, a squared plus b squared equals c squared, to work out the fact that this is going to be root 2. Because it's an isosceles triangle, this angle here is going to be 45 degrees, and same with the bottom right one, but we're not interested in that. When we label it with our marked angle here, we've got the adjacent is here and the hypotenuse is here. Now we know from trigonometry that cos x equals a over h. The angle is going to be cos 45, and a is going to be 1, and h is going to be root 2. Now, this is a bit of a strange one with 1 over root 2, because we need to actually be able to rationalise the denominator. And basically what that means, if you haven't done surds yet, or you aren't doing surds, is you times top 1 by root 2. And so we end up with root 2 over 2. So if you ever see 1 over root 2 is absolutely fine as an answer, but if you ever see the answer as root 2 over 2, the two are actually exactly the same. So writing 1 over root 2 is fine, or writing root 2 over 2 is also correct. So when we find the mean of something, we add the elements together and we divide them by the amount of elements. So here we've got 3 elements. So what we're going to do is add these together and then divide by 3. Now the problem is that the denominators are not the same, so we can't add them yet. But they're all factors of 45. So we're going to times top and bottom of the first one by 9. So we end up with 9k over 45. Times the top and bottom by 3, and so it would be 3 brackets k plus 1 over 45, and the last one is over 45, so we don't need to do anything for that. Then we can just add the numerators together, and I'm just going to expand the bracket here, so it's 3k plus 3 plus k plus 4, and then all of that over 45. And then we're going to do 9k plus 3k plus k, which is going to be 13k. And then 3 plus 4, which is just 7, over 45. So the sum of them is 13k plus 7 over 45. So to work out the mean, we need to divide it by 3. But instead of writing divide by 3, we know KFC, keep, flip, change. If you have a division, you keep the first fraction, you change the divide into a times, and you flip the second fraction. So a different and easier way of writing that is times 1/3. So here we just keep the numerator the same because we're timesing it by 1. And then the bottom we just times by the 3, which would be 135. So our answer is 13k plus 7 over 135. So I'm going to write this equation again just a little bit bigger so we can work with it. And one of the rules with equations is you want to get rid of brackets and fractions first. So we've got a big fraction here, and basically a fraction just means divide. So we're doing the 82 and we're dividing it by 3x plus 5. Notice I've put a bracket around it, because what we're going to do is we're going to do the opposite of divide by that bracket. We're going to times both sides by 3x plus 5 to get rid of that fraction. Now on the left hand side that just gets rid of the fraction, so we're just left with 82. On the right hand side, well, we're doing the 2 times the 3x plus 5. Following my rules to get rid of all the brackets first. So 2 times 3x is 6x, 2 times 5 is 10. And you can use any method you want. Some of you might use this method where we've got the 2 here, 3x plus the 5, and then we times them, so it's 6x plus 10. That's how we can do it. Any method you like. And then we're going to take away the 10 both sides because we want x on its own. And so we've got 72 equals 6x. And then we're going to divide both sides by 6. And so we've got 12 equals x, or x equals 12. So we're going to go through one way in which you can do this question. With circle theorems, often there are multiple different approaches, and so if you do a slightly different method, but you've written down all the working and you're happy with it, and you get the same answer, it's probably fine. Just don't forget with these, always show every step of your working out, because normally, say there's 3 marks for this question, 1 will be for the answer and 2 will be for the working out. So the first thing I notice with this question is that we have a lovely triangle coming off a tangent, and whenever we have that, the angle on the outside here is equal to the angle on the opposite side of the triangle. So this is going to be 44 here. I'm just going to remove all of that. And so this is going to be 44 degrees here. So angle BFD equals 44 degrees. And the reason you need to give is the alternate segment theorem. And you have to use those words, otherwise you won't get the marks. Now, next I notice that we've got a set of parallel lines here, and we've got a line going through them, and so the 44 degrees there is going to be equal to this one here, and so this is going to be 44 degrees. So we say angle FDE equals 44 degrees. And the reason this time is alternate angles, put the E in, angles. And again, you have to use the word alternate. Okay, next thing I notice is that we have an isosceles triangle here, here, and here. And the bottom 2 angles in an isosceles, assuming that it's upright, are always equal. So this is going to be 44 degrees here. So angle EFD is also 44 degrees. And again, we have to just say that it's an isosceles triangle. Okay, just highlight the fact it's an isosceles triangle. Okay, next thing we're going to work out is this one here. And it's just angles in a triangle. So angle FED is going to be 180, take away the 44 plus the 44. And the reason is angles in a triangle add up to 180 degrees. And so 180 take away the 44 plus the 44 is 92. 92 degrees. And finally, took us a while to get there, but finally we can work out what this angle is, because in total all 4 corners of this quadrilateral here are touching the circle, so it's a cyclic quadrilateral. And so angle what's it called in the question? Angle FBD is going to equal 180 take away 92. And again, we have to show the reason of the fact it's a cyclic quadrilateral. And so 180 take away 92 is going to be 88 degrees. So our answer will be 88 degrees. An exponential growth would show an increase from left to right, but the graph we've got in front of us, or the sketch, is showing it decreasing, so it's going to be a decay. We have a expression with f of x in, and we're given what f of x is. So what I'm going to do is just write out this expression again, but instead of f of x, I'm going to write out what it says it is. It says it is 2x plus 5. And notice I've put it in brackets as well, because f of x is the whole of that, and then plus 4. We're just going to expand the brackets, and that will make 10x plus 25 plus 4. And then 25 plus 4 is 29. So the answer would be 10x plus 29. So the frequency is kind of equal to the frequency density times the class width. And I say kind of because it's actually a proportional relationship. The frequency density doesn't have to be that value, it can be twice the value or half the value. But we're going to assume it is because we can check whether it is by the value given to us in the question. So going through each of the groups, the first one is 0 to 10 and it has a frequency density of 0.2. So we're just going to do 0.2 times 10, which will be 2. The next one has a width of 20 and the frequency density goes up to 0.8. So 0.8 times 20 will be 16. And the last one is a class width of 20 and it goes up to 1.2. So we're going to say that that frequency is 24. So if you do 24 plus 16 plus 2, you actually do get to 42. So we know that that is frequency equals frequency density times class width. Okay, now it says to estimate the amount of rocks that were greater than 15 kilograms. So we're going to draw a line up from 15 kilograms. And we're looking for all the values that were to the right of that line. So we know that there are 24 definitely, okay, because all of that bar is to the right of that line. And we've just got to work out what proportion of this bar is to the right of that line. Well, it's 4 squares wide and we're looking at 3 of the squares. So it's going to be 3/4 of 16. So the amount we're looking for, so rocks, is going to be 3/4 of the 16 plus the 24. So the 3/4 of the 16 will be 12 plus the 24, which will be 36. This question is all about completing the square, but we've got to do something first. We have a coefficient of the x squared there, and we want to get rid of that. Whenever we do the completing the square, we need to have just x squared on its own, ideally. So we're going to divide out that 3, and so we're going to have 3 brackets, and then we're going to have the x squared minus 10x, close brackets, minus 11. Then we're going to complete the square with x squared minus 10x. So we're just going to copy in that 3 brackets. And how we do this is we create a bracket and we put the x at the start minus half of the coefficient of the x. So half of the 10 would be 5. Close bracket, squared. Now I'm going to leave that half done because down here I'm just going to, well, across here I'm just going to expand that and show what that creates. So x times x, so that's the same as x minus 5, x minus 5. So we get x squared minus 10x plus 25. So notice here it creates this plus 25, which we've got to deal with. And we deal with that by removing the 25, which we do here. Close brackets, minus 11. So the blue parts haven't changed. The kind of turquoise parts are the completing the square bit, but the minus 25 just removes that 25 that the x minus 5 squared brackets create. Okay, so we need to get that minus 25 outside the brackets. So we're going to expand the brackets slightly. Going to leave the 3 on the outside of the x. In fact, let's keep the color scheme going. So we're going to have the x minus 5 squared bit there. 3 times minus 25, it's minus 75. And then we've got this minus 11 at the end. Okay, and we're very, very close to finishing. All we need to do now is sort out the minus 75 and the minus 11. And when we subtract those two, we get minus 86. Now the m part is going to be 3. The p part inside the bracket is going to be minus 5. And the q part is going to be minus 86. Here we've got a cubic graph, and we're asked to find out what the equation would be if it was in this form here. So first of all, notice that we've got a negative cubic. A positive cubic looks like this. So we've got a negative cubic, and there is a minus sign there that just deals with that. So we don't need to worry about the fact it's a negative cubic, because that minus sign just means it's negative, fine. Next thing we want to do is find the roots. So the roots are where the line crosses or touches the x-axis. So here we can see it touches it at 6, so when x equals 6. And here, now this is an interesting one, it actually touches it twice. It touches it at -7 the first time going down, and then it touches it at -7 going up. So there's technically 2 roots there. Sort of one root, but it counts twice because it's going down on one root and then up on the other root. So with these, what we need to do is we need to make sure that at x equals 6 and x equals -7, that this equation, the whole thing equals 0. So if we imagine A, what does A have to be to make this whole thing equal 0? When we look at this, the fact that a root is at 6. Well, if we put A at -6, we get x -6 in that bracket there. And if we put in the value of 6, then it's 6 minus 6, which is 0, and so the whole thing is 0, because anything times 0 is 0. So if A is -6, let's have a look at B. So what does B have to be? Well, if that's -7, if we put B as +7, then when we substitute in this -7 here into the x, we get -7 plus 7, which is 0. So if B is -7, then the whole, +7, then the whole thing will be 0 at x equals -7. And for the C, we're looking at that last root. Again, it'll be the same, won't it? It'll be x plus 7. Now, you might ask the question, how do you know which is A, which is B, which is C? Actually, it doesn't matter. We could put A at -6 and A at 7 and B at -6 and C at 7. As long as one of these is -6, 1 and 2 of these are 7, you'll always get the right. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.